To understand working with negative bases, it helps to think about our property where we have an exponent that's being shared with multiple bases. So let's distinguish between this first example, 2 times 3 squared, and the second example where we have 2 times 3 in parentheses squared. And think for just a minute about the difference between the notation in these two. We're going to use our order of operations. So in the first example, what would you do first? What operation? We have multiplication and we have exponents. What operation would you perform first? If you said squaring, you're right. 3 squared is 9. Now we multiply, so what do we get? 18. Good. All right, let's look at the second example. We have multiplication and an exponent here. What do we do first? Hopefully you said multiplication because it's in parentheses. So 2 times 3 equals 6. And now we're going to raise that 6 to the second power. So what's 6 times 6? 36. So you can see that these give you two different values, and it's because of order of operations. So let's move on to negative bases and apply this idea. So let's say that we have the following problems. Let's say we have negative 3 squared and we have negative 3 in parentheses squared. Well, negative 3 could be looked at as negative 1 times 3. So in our first example, we would have negative 1 times 3 squared. In our second example, we'd have parentheses, negative 1 times 3 parentheses squared. So what do you think the difference is between these two? Again, order of operations, right? So in the first problem, what do you do first? Multiply or exponents? Our exponent, right? So we have negative 1 times 3 squared, which is what? 9. And what's negative 1 times 9? Negative 9. In our second example, we have negative 1 times 3 squared. So what do we do first? Do we multiply or do we do our squaring first? Hopefully you said multiply since we have parentheses around multiplication. So we're going to multiply to get negative 3, and then we square. Well, negative 3 squared is the same as negative 3 times negative 3, which is what? Positive 9. So you can see again this gives you two different values. Let me show you another way to think about this. So let's look at the same two problems and just another approach. It doesn't matter which approach you use. So if I have negative 3 squared compared to negative 3 in parentheses squared, another way to think about it is the exponent again only goes with the 3 in my first example. It does not apply to the negative. So you could think about this as meaning the opposite of 3 squared, or 3 times 3. So the opposite of 9 is negative 9. In the next example, again, you can think about the square as being applied to both the negative and the 3. So this actually means negative 3, the whole thing, times negative 3, or negative times negative times 3 times 3. You can think about it either way. Either way, you have an even number of negatives being multiplied times each other. And if we have an even number of negatives being multiplied or divided, what sign do we end up with? An even number of negatives will give us a positive sign if we're multiplying or dividing. So that gives us positive 9. So there's just a couple ways to think about negative bases and exponents. Now let's move on with some examples where we have negative bases and negative exponents, but let's review what a negative exponent is. Suppose we have 3 to the negative second. What does a negative exponent mean? Does it mean that my base is negative? Well, if my base is negative, there would be a negative in front of it like we saw in the previous problems, right? So this is an example with negative bases, but notice the exponents are not negative. Well, here my base is positive, but my exponent is negative. So what does it mean? It means reciprocal, right? It means reciprocal. It's what a negative exponent means. And when you write this as a reciprocal, the exponent becomes positive. So we need to think about this number as a fraction in order for us to visualize the reciprocal. So I'm going to put it over 1. Anytime we have a whole number, we can write it over 1 to see it as a fraction. So I'm going to reciprocate. I'm going to flip this fraction upside down so the numerator becomes the denominator and the denominator becomes the numerator, and then our exponent will be positive. So what does 1 over 3 squared equal? 1/9, right? Okay, so now that we've reviewed that, let's throw in negative bases. So let's say I have, again, negative 3 to the negative second and negative 3 in parentheses to the negative second. Well, we're going to want to deal with the reciprocal before we deal with applying the exponent. You always want to do the reciprocal first. So let's look at this first one as negative 3 to the negative second over 1. When we write the reciprocal, we'll get 1 over negative 3 to the positive second. So the negative exponent only means to flip this upside down. That's all it means, and then it becomes positive. The negative in front of the base means that the number is negative, so we leave that there. Now we need to apply our exponent, and we've learned that that negative in front of the 3 actually just means opposite. So this is 1 over the opposite of 3 squared, which is 9. So that's 1 over negative 9. Now I want to remind you that a negative fraction can be written with the negative in the numerator, the negative in the denominator as we've already seen, or the negative right beside the entire fraction. These all mean that the fraction has a negative value. Let's look at the next example. Negative 3 to the negative second. I'm going to write that down here so we can focus on it. Again, we would like to work with the reciprocal before we start working with actually squaring, because we need to see what the exponent is when it's positive before we actually apply it. So when I write this as a reciprocal, I have 1 in my numerator, negative 3 in parentheses to the positive second power in the denominator. So now I'm just going to apply the exponent. And we know that when our number is within parentheses and it has a negative, we go ahead and square the whole thing. So that actually means negative 3 times negative 3, which is positive 9. So our answer is 1 over positive 9, or 1/9.